gases in many forms. Example like mechanical, gravitational, and sonic. But today we are talking about the first law of thermodynamic. As the name thermodynamic, we can know that it is something related to heat. The first law of thermodynamic is discovered by Rudolf Clausius in the year of 1850s. This is study about the internal energy and is well known as the principle of energy conservation. The first law of thermodynamics also stated that energy is always conserved and it cannot be created or destroyed, but it could be transformed. The formula for the first law of thermodynamics is delta U equals to Q minus W, where delta U stands for the change of internal energy and Q stands for the energy added to the system by heating, and U it stands for the work that done by the system. Let's try a question with that formula. 2,500 joules of heat is added to a system and 1,800 joules of work is done on the system. What is the change in internal energy of the system? First of all, we should write down the formula. Then we should know that what we are finding and what is given in the questions. So in this question, we are finding for the delta U, change in internal energy, and it's given Q, where it's 2,500 joules, and W, where it's minus 1,800 joules. Maybe you'll be asking, why does this minus? It's because in the question it stated that it's done on the system, but in the formula we need by. To change on to by, it is equal to add a minus. Delta U will be equals to 2,500 joules minus negative 1,800 joules, and it will become 2,500 joules plus 1,800 joules, and the answer is 4,300 joules. Now, let's look at the first law of thermodynamics extended. To write the first law of thermodynamics in a more complete form, consider a system that is moving so it has kinetic energy, Ke, and suppose there is also potential energy, P. Then the first law of thermodynamics would have to include this term, and it will be written as change of Ke plus change of Pe plus change of U equals Q minus W. It's the same like the normal one, just that plus change of kinetic energy and change of potential energy. The last topic for today's video, it is thermodynamic process. First, it is isothermal process. In this one, it have constant temperature, and when temperature is constant, delta U becomes 0. The second one, it is adiabatic process. This one, no heat is transfers, so Q becomes 0. The third one, isovolumetric process. In this one, the volume is constant, so the work, the W, becomes 0. The fourth one, it is isolated system. It is when Q equals to 0 and W equals to 0. That's all for today. Thank you for watching.